Alright, for 27, I went ahead and labeled like the open and the closed dots right here. Because remember, this is the domain that tells you where each of the three pieces starts and stops. Okay, so for this one, the first one, it's for all x less than -2. So I put a -2 here, and I got 4 minus 2 is 2, and that's how I got this open dot. And then right here it says it includes -2, right? And the y value is +2, so that's where you get this point. And then this open dot right here, you have a 3 that's not included, and then it's still equal to 2. Okay. The third piece is it starts at 3, and so you replace the 3 here. 3 times 2 is 6, minus 4 is 2, and that's where that point comes in. So I also drew these lines here that divide it, the graph into 3 sections. And how do you do that? You look at the numbers in the domain, so -2 and 3. And that's where you draw the vertical asymptote type of lines. And then I labeled each section. So the first section is x plus 4. Why? Because it's less than -2. The middle section is 2, because that's what the middle section says right here. Between -2 and 3, I have my graph is at 2. And the third section is x greater than or equal to 3, so that's this one right here. So now I'm going to plot the points, the open and closed dots. -2, 2 would be open right here. And it's a line, right? X plus 4, slope is 1. So I could either go up 1 over 1 to the right, but I can't because it would go into the middle region. So the only other thing I can do is go down 1, left 1. That's still +1, right? Down 1, left 1, down 1, left 1, and so forth. And so connect the points. The middle section is a horizontal line on 2, on y equals 2. The left side is closed, so it closes up the whole the open dot. Go across, and this is open. Okay? The third section is a line with slope 2. The first point is at 3, 2, so, and it's included, it's closed, so it closes the open dot right there, and it's up 2, right 1, up 2, right 1, and so on. You could keep going that way. It's a line, oops, and it goes like that. So there's the graph. Okay, so for 28, they're asking you to subtract f minus g, and here's the setup after the equal sign. So we're going to distribute, get rid of parentheses by distributing the -1. So minus a negative is +6, and then minus x. So don't forget to distribute this negative over here, right? 6 minus 6, that's 0. 4 minus x, that's 3x. For number 29, they're asking for the domain of f over g of x. So I've set it up already after the equal sign. So when they ask for the domain, we always look at the denominator to see if there are any values that are not allowed. So we know that if 2x minus 6 equals 0, then it would be undefined. So what would make that 0? That would be x is 3. That would make the denominator 0. So we say the domain is all real such that x cannot equal 3. Alright, so we're doing f of g for this one. So this is the inside function. This is the outside function right here. So that means we're going to set it up like this. 8 blank squared, and in the blank we're going to put in the x minus 2, the g of x. And you can distribute, so that would give you x squared minus 4x plus 4, and then distribute the 8. So that'd be 8x squared minus 32x plus 32. Alright, so for 31 they want the f of g of x plus the domain of the composition. So this is the inside function, this is the outside function. So the domain of the inside is all reals. So we're coming in with all real numbers into the composition. So we write it like this. In the parenthesis, in the blank, we're going to fill this in with x squared minus 9. So when you simplify this, the 9's cancel out. 9 minus 9 is 0. And so you're left with the square root of x squared, which becomes x. Okay, and the domain for this would be all reals. Alright, so for 32, one thing you could do, you see it's a quadratic, so you know it's a parabola, so it has a vertex. So we can find the vertex by using the negative b over 2a for the x coordinate. So that would be negative b, which would be minus negative 2, 2 times negative 1. So that would be 2 over negative 2, which is negative 1. For the y coordinate, we just replace the x's with negative 1. So that would be minus negative 1 squared minus 2 times negative 1 minus 4. So this is 1, negative 1, positive 2 minus 4. So that would give you negative 3. So the vertex is negative 1, negative 3. You know it opens down because of the negative in front of the x squared. And the a value is negative 1. So it's going to go. So negative 1, negative 3 is the vertex. So it would be here. And because the a is negative 1, we know it's going to go here and here. You can replace the x with a 0, and we know that the y-intercept is negative 4. So that's how I knew this point. And I know the parabolas are symmetric, so that's how I knew to graph it at negative 2, negative 4 also. So, oops, I missed that point a little bit. It goes something like this. Alright, so this quadratic is already set up for you in what do you call it, vertex form. So I'm just going to use transformations to graph it, as you could see on the screen. But what I did first, notice that I squared the 2, this one that's inside the brackets, and then I just left this in squared form right here, the minus 5. And then h is 4, so it's x plus 4, and a is 4, and k is negative 5. Okay, so now I'm going to transform the points. So that's going to give me negative 1 plus 4 is 3. 4 times 1 is 4, minus 5 is negative 1. 0 plus 4 is 4, and 4 times 0 is 4 minus 5. 1 plus 4 is 5, and 4 times 1 is 4, minus 5 is negative 1. So now we're going to plot this. Alright, so 3, negative 1, 4, negative 5, and 5, negative 1. Okay, now it's not a V shape, it's a parabola. So try to make it curvy, like not a straight line. So kind of curvy, something like this. Alright, so for the vertex, I used negative b over 2a for the x coordinate. And so you see the work right here. Minus a negative 20 divided by 2 times 2, because a is 2, and that gives you 5. And then I replaced all the x's with 5, so here, and I simplified, and so that gave you negative 8. So the coordinates are at 5, comma, negative 8. Alright, so the next part is to find the x-intercepts. So remember, x-intercepts means that y is 0. So I changed the g of x to 0, and then I factored out a 2 out of all the terms. And you're left with that last line right there. So then you ask yourself, what are factors of 21 that add up to 10, to negative 10? And that would be negative 7 and negative 3. So x minus 7, x minus 3, which means that the x-intercepts are 7, 0, and 3, 0. That's what makes each of these factors a 0, right? So 7 and 3. So these are your x-intercepts. So for 35, they're asking you to write the function in vertex form. You could do completing the square for this. You could also do the negative b over 2a, and that's how I set it up. So that gives me negative 6 over negative 2, which is positive 3. Then I replace the y with, the x. To find the y, I replace the x's with 3, and so that gives you negative 3 squared plus 6 times 3 minus 5. So that gives you 9, right? 3 squared is 9, but there's a negative in front. So negative 9 plus 18 minus 5, so that's 9 minus 5, which is 4. So the vertex is 3, 4. So you, and the A value is negative 1. You see that right here. So you write your f of x equals negative x minus 3 for h. H is 3 squared and k is 4. And that would be the function. Alright, so we're going to start off, I know that this is not standard form, this is vertex form, but we're going to start out with vertex form in order to get standard form of the quadratic. So I know vertex is 3, 4, and it crosses through 4, 0, the point 4, 0. So I'm going to replace, this is your y, right? So I'm going to replace that with 0 because this is 0, equals, we don't know a yet. An x value of the function is 4, minus h is 3, and k is 4. So we subtract 4 from both sides, and so you get negative 4 equals a times 4 minus 3 is 1, 1 squared. 1 squared is 1. So we know a is negative 4. So we write it as f of x equals negative 4, x minus 3 squared plus 4. And so now all we do now is multiply it out. So remember your order of operations. First we square, then we distribute the, oh, don't forget the plus 4. Then we distribute the negative 4. Don't forget the 4, and then we combine like terms. So final answer would be this. So for 37, it's asking you to give the end behavior, the left and right. You could put it in standard form or just identify the term with the highest degree or with the highest power. So that would be this one right here. Okay? So this one's going to determine the end behavior. So it has a negative a and an odd exponent. So that means it's going to go like the end behavior are going to be like those of a line with a negative slope. Okay, so it's going to go like this. So you would say as x goes to negative infinity, f of x goes to infinity. As x goes to positive infinity, f of x goes to negative infinity. So as we go to the left, the graph goes up. As we go to the right, the graph goes down. All right, same instructions on number 38. They want the end behavior. So this is the leading term, the one with the highest power degree, power 5. So now it's odd degree with a positive a. So the end behaviors are going to act like a line with a positive slope. So it's going to go kind of like this on the left and like this on the right. So you say as x goes to the left, y goes down. As x goes to the right, y goes